Most welcome student. Today we are discussing the very important topic. This is imperfection of the crystal. Clear? We are discussing the imperfection of crystal, or you can say that this is a defect of crystal. This is an important topic of solid state, and this is called imperfection of crystal, or this is also called defect of crystal. These are two types. First one is intrinsic, means pure, or you can say that this is native disorder, means molecule are dislocate from its position in its natural state. And the second one is this is extrinsic. This is called an extrinsic disorder, means some impurities are mixed in it. So these are the two defects on the basis of the pure impurity, you can say that. Clear? Now, after that, we are also divided on the basis of there are two defect on the basis of arrangement. The first one, this is line defect. In a line defect, you must remember that dislocation of an element from line or layer. एक क्लियर क्लियर गायब हो जाती है, so this is a called line defect. And the second one is this is point defect. In a point defect, you must remember that removal of atom from its place. Clear? So these are the two defects. And after that, we are actually discussing the type of point defects. We are discussing now we are discussing the type of point defect. Clear? Now you see it. First one is this is stoichiometric. Second one is non-stoichiometric. non-stoichiometric. In a stoichiometric, we are coming the first one. The first one we are discussing vacancy defect. In a vacancy defect, atom or molecule move outside of crystal. Density of crystal decrease. Such defect happen in covalent compound. Clear? So this is vacancy defect. Atom and molecule are moved outside of the crystal, density of crystal decreases. Such defect happen in a covalent compound. Now, after that we are coming the next one in a same stoichiometric defect. This is the second one is interstitial interstitial defect. Atom or molecule never move outside but dislocate and store in interstitial or interatomic space. It may be happen in covalent compound. There is no change in density of crystal. Clear? There is no change in the density of the crystal. And the point of remembering is These defects are mainly thermodynamic defect. This is thermodynamic defect produced by heating. Produced by heating. ये किससे होते हैं पैदा? ज़्यादा हीट मिलने की वजह से ये प्रोड्यूस होते हैं, एक्स्ट्रा हीटिंग की वजह से. क्लियर? Now these are the two defects, and after that we are coming the next one. And the next one is, this is a very important. This is Schutke defect. Dislocation of pair of electron, pair of, not electron, pair of ions, means cation and anion, and move outside of atom. Dislocation of pair of ions and move outside of the outside of crystal. Move outside of the crystal, not atom. Means this is type of vacancy defect. Clear? Density density of crystal become decrease. Clear? And next point of remembering, there is large difference in sizes of cation and anion. This is a large difference in the size of cation and anion. Clear? Next one, the coordination number is very large. Occur in octahedral and cubic arrangement. Remember that the coordination number is very large and in octahedral and cubic arrangement. Occur in cubic and octahedral arrangement. And next point of the remembering is that there is a small electrical conductivity. Clear? Number of Schottky defect is produced in n is equal to n e e base 2 kt. N means number of Schottky defect. This is a representation of number of Schottky defect. N means Avogadro's number 6.023 into 10 to the power 23. Ke is energy. K is Boltzmann constant. Its value is 1.38 into 10 to the power 23 joule per Kelvin. Clear? So this is the main points of the Schottky defect. You must be know that. And after that we are coming the next one. This is called Wrinkle defect, means a fourth one. We are discussing the fourth one. This is Wrinkle defect. You are concentrate in its name. Wrinkle means free, means no change in a density. ठीक? You must be remember that it is type of interstitial defect. Dislocation of atom. Atom or dislocation at its place and is stored in interatomic or intermolecular space. Dislocation at its place and is stored in interatomic or intermolecular space. Clear? It present in ionic solid. Schottky defect is actually also produced in ionic solids. No change in density. No change in a density. Clear? And Number of Frankel defect means n is calculated by n is equal to square root n upon ni e की base e to kt. Same value whatever in a are in as we are discussing in a Schottky defect. Ni means the number of interstitial sites, number of interstitial site. Clear? Example, how many type of the compound show the Frankel and the Schottky defects? Now we see it. Example, AGBR, AGI, ZNS give this effect. Clear? AGBR give both defect Frankel and Schottky. Clear? Due to there is a less difference in a AGBR, so it give the also a Schottky defect. Clear, student? So today we are discussing the different of the defects. In the next class, we are discussing the remaining parts of defects. Now, thank you and thanks a lot. And Jai Hind.